My name is Dr. Eamon Doyle. I'm the geologist with the Burren and UNESCO Global Geopark. My work as a geologist, and like all geologists, we look at interpreting the rocks. And that is extracting the story that's hidden in those rocks and making it available to everybody or whoever is interested. So we look at the history of the Earth, and the history of the Earth is recorded in rocks. The rocks that we have here in the Burren are approximately 330 million years old. So that's the first thing, and it's a big thing because that's a huge number of years. So we're looking back in time. When we look at these rocks, we're looking at events that happened 330 million years ago. And to put that into context, that's before the dinosaurs even evolved. So there was no dinosaurs that hadn't even started to evolve at that point. So it's a long period back in time. So an awful lot can happen in 330 million years. So there's the story of what was happening when the rocks formed, and then there's a subsequent story of what happened after they formed, how we got from that time to where we are now. It's a long, complex story. It's absolutely a fascinating story. And the story of what happened to the rocks and how they got here is just as important as the story of what's happening now, what's happening to the rocks, what's happened to our landscape, what's happening in terms of climate change globally. It's all connected. To figure out, one of the big issues of today is how humans are influencing the climate, global climate. So we talk about climate change. The climate has always changed. That's not an issue. The issue now is how much of an impact our activities, our human activities, are having on the planet. We know that the organisms that live on this planet affect the atmosphere, affect the climate. We are another one of those organisms, and we are now of such a scale that we are having an impact on the climate. All the scientists, all the studies indicate that that is actually true. We're not the only thing that's affecting the climate, but we are an important part of that, and an increasing part of that in many ways. So in order to understand the role we're having now, we need to understand the natural climate change that occurs on Earth without humans. So we can extract one from the other and say this is the role of humans. So we can do that by looking back at how climate was changing 330 million years ago, for example. You don't have to go back that far, but the rocks in the Burren are 330 million years old. And that climate change was happening without the influence of humans. There was no humans there, so we can say whatever was happening there was completely natural, if you like. Also, I think it's important to point out, and this is a little bit of an aside, we often think that the climate change that we are influencing as humans is considered not natural. It is natural because we are organisms that evolved on this planet. We are as much natural here as the algae, the trees and the grass. We evolved here, we are having an impact, everything has an impact. So we just need to look at it that way, rather than saying we're different, we are actually a part of it. But we also have the advantage that we can change our impact. So 330 million years ago, everything was different. If you look at a map of the Earth 330 million years ago, you will not see the continent of Africa, you will not see America, you will not see Australia down there, you will not see the Atlantic Ocean. The continents were different. So on the surface of the Earth, the continents move around slowly over time. Very slowly, about 2 or 3 centimeters a year. So the plate we're on now is moving as we're sitting here. It's moving 2 or 3 centimeters a year, which is about the length of the speed that your fingernails grow. So it's a slow process, but it's a continuous process. And because we're talking about hundreds of millions of years, an awful lot can happen. So the way the continents were arranged back then, they were pretty much all together. They were more in the southern part of the Earth, and it was essentially one more or less continuous continent. There was different continents coming together and colliding. So the landscape of the Earth was different. There was a huge area of ocean, and on the South Pole there was ice forming. Where the Burren was, where this landscape, the limestone landscape we're in now was near the equator. Obviously we're not near the equator now. We're quite far north, so somehow we got from the equator up to where we are now. But what was happening near the equator at that time was, if you saw a picture of the landscape, it would look very much like the Bahamas does now. So it would be shallow, warm waters, clear waters, a lot of corals, a lot of growth in the ocean. So we were on a sea, we were on a fairly shallow seafloor. There was corals growing, there was fish swimming, there was crinoids, there was calcareous algae, lots of creatures growing, living, breathing, and dying. And what they were doing was, a lot of these creatures have shells. So the corals, for example, they have a skeleton structure that's made out of calcium carbonate. The brachiopods have a shell structure. The trilobites have a shell structure. So these guys were taking minerals from the water, making their shells, living there, and then dying. And as they died, they basically fall to the bottom of the sea. It's a sea, there's winds, there's waves, they get broken up, they get reworked, there's storms coming in from time to time. They basically break up, fall apart, and form essentially the sand on the bottom of the sea. Most of the rock in the limestone, if you look at it very closely under a microscope, you take a piece of limestone, break it open, polish it up, look at it, you'll see it's made up of tiny fragments of fossils. Sometimes it's hard to see them on the surface, but if you look inside, you will see them. And that's what it's made up of. It was made up of fragments of creatures that were alive 330 million years ago. So as they settle on the seafloor, they get reworked. Eventually they start to cement and turn into rock. Because there's so much calcium carbonate in the sea, they turn into rock fairly quickly. But then they get buried. There's another corals grow on top of that. They die. More corals, more brachiopods, they die. And we have a lot of millions of years. This is happening steadily and slowly. The layers are building up. And as they build up, the weight they get pushed down. So this is how the limestone is actually formed. So it is the remains of creatures that were alive 230 million years ago. And it records pretty accurately the creatures that were there. So this process went on for 10, 15, 20 million years. And layer upon layer of these fossils were dying, living, breathing, dying, living, breathing, and accumulating and forming rock. And it was getting very deeper and deeper and deeper. So this thickness of limestone was formed. If you look at the layers in the Burren, if you're out on the rock, you'll see these kind of layers. Each of those is one unit within that. Each of them took hundreds of thousands of years to form. Some cost maybe less, 10,000, some 100,000. But long periods of time to accumulate this. So very steady conditions. It was all tropical sea, fairly shallow. We know it was shallow because the light could get through these creatures. Some of these creatures needed light to live. So the sea was maybe only 20, 30 meters deep in some places, less in some places. So this was a very broad platform of sea, and it was just sinking slowly, but accumulating the sediment and maintaining more or less a steady position. So everything was very consistent for a long period of time. Within that time, though, there are some areas where, because it's not just limestone, we get little thin areas of shale. And this is composed of essentially mud, organic mud in some cases, and that poses a problem then. Why is that shale layer there? And what was happening, what we believe was happening was because we were in a shallow seafloor, if you imagine the sea level up here, seafloor down here, every now and then the sea level was dropping. And as it dropped, it exposed the limestone seafloor. And what happens then is that gets eroded. Plants can grow on it, and it forms a kind of a mud. Soil, essentially. And then sea level rose again because we get limestone on top of that clay there. So sea level was rising and falling, rising and falling. Every time it fell, the limestone was exposed, it was eroded. Every time the sea level rose again, it returned exactly the way it was before. It was a shallow marine condition. You get in the corals, you get in the brachiopods, everything growing as it was. So we have this cycle of sea level rising and falling over hundreds of thousands of years. And this fluctuation in sea level was being controlled by the ice. So there was an ice age happening at that time, and it was a very long period of ice. And as the ice sheets were growing, they expanded, and the South Pole primarily, they were taking the water. So there was no fresh water flowing into the sea, so sea level dropped. As the ice sheets melted, sea level rose again. So we have this period of sea level fluctuation going up and down, up and down. And this is exactly what was happening. So that's 330 million years ago. This is exactly what was happening 20,000 years ago. So a huge time period, more than 300 million years, and we see the same effects. The last glaciation, the last ice sheets that formed in northern Europe were formed exactly the same way. ice sheets, this time mostly in the northern hemisphere, were expanding and contracting and expanding and contracting, and as they did so, sea level rose and fall and rose and fall exactly the same way. So we have an exact analogue in some ways of what was happening 330 million years ago, and what happened much more recently in our recent past. The ice sheets that expanded 20,000 years ago are the last major event that shaped the landscape of the Burren now. So they may have been 200 meters thick, solid sheets of ice pushing over the landscape, grinding it up like a huge bulldozer, a huge digging earth machine, grinding up, ripping up any loose rock, and then dumping it somewhere else. And then the ice sheets melted again. And then they expanded again, they pushed out, and they did the same thing again. So we have a very direct connection between the limestone and the history of what was happening at 330 million years ago and why it's actually the current shape it is now. The hills and the valleys, they were all shaped directly by the ice. In terms of, so we know this is a natural part of the Earth cycle. The ice sheets expand, they contract, they expand, they contract. Some periods of time have them more, some periods have them less. We're just finished with a period now that's had the ice sheets. 10,000 years ago, 20,000 years ago, to a geologist is no time at all. It's like a second ago. So we are still in that period. The ice literally has just melted an instant ago, 20,000 years, 15,000 years ago. In the natural course of events, the ice would return around now. Typically, there's a period of about 10, 15,000 years between when the ice accumulates and when it melts. So the warm period in between is usually about 15,000 years. So we've had the warm period, we should be returning into a cool period now. One of the issues then is maybe we're not, because of the carbon dioxide and the methane and the other gas that we're putting into the atmosphere, and that has changed the dynamic of the atmosphere. So perhaps we have put off that next ice phase. Climate has continuously changed. We know that there's a natural cycles, we know there's ocean currents move. As the plates themselves move, they change the ocean currents. So this is a constant dynamic. As we rotate around the sun, as we spin, there's a slight wobble, the amount of solar radiation that affects us, that hits the Earth, that all affects climate directly. But now man is adding to that. One interesting aspect of the limestones and the geology of around here is that we have fossil plant material. So after the limestones formed, there's another layer on top of that, the sandstones and shales. And within that, we have layers of a lot of plant material. And this is the same plant material that forms coal elsewhere. There's no real coal, there's very thin seams here in the Burren, but it's the same age, exactly the same formation as the massive coal that they have in the UK, in Germany, in North America, and a certain little bit in Ireland as well. And this coal is absolutely critical to the whole story, because at that time, these plants were growing up. They were like trees, they had trunks, they had leaves, they had branches, and they were taking the carbon dioxide out of the air to make their structure, to make the carbon that forms the leaves and the plants and the structures. And then they were falling down and dying, natural cycle. They were falling down into a swampy area. And the swampy area is a little bit more acidic, so the plant material doesn't get decomposed, so it gets preserved like that. So these were large swampy areas storing the carbon from the atmosphere. So the plants were taken out of the atmosphere, storing it there. This is considered to be directly related to the climate that was changing at that time. So we were into a period of ice ages at that time. So the very ice sheets that were causing these fluctuations in sea level, the plant material taking the carbon dioxide out of the atmosphere contributed to the cooling of the Earth at that time. So we have all this carbon dioxide being taken out of the atmosphere, being stored in these vast swampy areas. And like I said, we're very extensive. The Burren here is just a part of it, but they were all over North America, all over Northern Europe. So they were a significant factor on the atmosphere at the time. So these layers then get buried. As they get buried deeper and deeper, they eventually turn into coal. If you heat up that amount of carbon and that plant material, it will change chemically and will turn into coal. So now you fast forward 300 million years, and people start taking this coal out of the Earth. They realize this is a very good source of fuel. You burn it, it gives off heat. And then you take more and more of that out, and you take more and more of that out. And what you're doing is you're taking that carbon, and the carbon dioxide basically, that was stored in the Earth 300 million years ago, you're taking it out, burning it, and putting it back into the atmosphere. So you're undoing what was happening back then, doing the opposite effect. So back then, the plants took the material, the carbon dioxide out of the atmosphere and stored it. We are now putting it back in again. So what was forming a cooling effect back then, you reverse that, you're going to have a heating effect now. So we can directly link the geology of this area, of this time period, in particular the carbon influence area, because most of the coal, especially for the Industrial Revolution, it was all this age, it was all this stuff they were taking out. And then they started burning that and putting that and other gases into the atmosphere. And that's when we noticed the stark decline in temperature globally. And that has accelerated. There's more people now, there's more cars, there's more carbon dioxide and methane going into the atmosphere. So there's a direct link between how we use the resources of the earth and the effects they have. So right now, if you go out on the Burren landscape, you're going to see a lot of bare limestone. This is unusual. One of the reasons why the Burren is a geopark is because it has such a vast expanse of bare limestone that's exposed, so you can go out and you can see the rock directly. And one of the very interesting things about limestone, even though it's extremely hard, if you hit it with a hammer, you need a hammer to break it, it's extremely dense, it's extremely hard, it dissolves from rainwater. It dissolves from water. So when rain falls through the atmosphere, it picks up a tiny, tiny little bit of that carbon dioxide and turns into a very weak acid. Very weak. It doesn't affect your skin. And this is natural. I'm not talking about acid rain, which is due to industrial pollution. This is just natural carbon dioxide. So the rain absorbs it. It always has done. And it gets weakly acidic. When that rain then lands on the soil, the organisms within the soil produce more carbon dioxide. So the bacteria, they're using that. And the water in the soil then gets even a little bit more acidic. That soil then hits the limestone surface, and because it's a weak acid, it dissolves it. There's a chemical reaction that goes on there. And you can get a little bottle of weak hydrochloric acid, put it on the limestone, it'll fizz. And it's essentially the same reaction, but just slow down an awful lot. So again, because we've got such a long period of time, all that water is going onto the limestone, it's dissolving it. And it will flow down along these cracks in the limestone. Everywhere you go in the Burren, you're going to see these cracks. And most of them are directed more or less north-south. It's about 10 degrees east of north, the main ones. And then there are other cracks at 90 degrees to that. And when the water flows down those cracks, it starts to dissolve the sides of them, and then it dissolves more and more. A bit of soil can get in there, and then plants will grow. The soil gets trapped in underneath these cracks. So the soil can come from leaves from plants, it can come from the waste from animals, and just a little bit gets accumulated in there. And these plants, a variety of plants, and invertebrates as well, will grow in there and have their home. It's sheltered. You're in these grikes. Sometimes they're about this wide. They can be a couple of meters deep in places. Sometimes they're quite shallow, it depends. But these are produced by water on the surface dissolving through these cracks. The cracks themselves are fascinating because they are directly linked with what was happening 300 million years ago. Because as the continents 300 million years ago were coming together, forming this large continent, they were colliding. So when I say colliding, it's not like a car crash where they go like this. Still, again, it's 2 or 3 centimeters a year on each side. So they're colliding. And as they collide, much like the way India is crashing up into Asia right now, when India is crashing into Asia, it's pushing it up like that and forming the Himalaya mountains. Huge forces. 2 continents colliding, massive forces. It will build a huge mountain chain. And that's what's happening. The Himalayas are growing. They're also eroding at the same time. Back then there was plates colliding together. We weren't right at the contact. We were a little bit further away from the contact. So we didn't get the full impact. So the rocks weren't completely messed up and destroyed where we are now. But what happened was the stresses built up. And the stresses were building up and up. And if you push like that on any rigid structure, at some point it will break. And what happened was the stress is coming this way, the rocks fractured that way. And these fractures, there's millions of them. Every meter, every 2 meters, every half meter in some places you'll see these cracks. So the whole limestone, because it was rock at that point, it was hard, it shattered as a result of these plates coming together to form this one supercontinent. So it's those cracks then, when they opened up, they opened very deep, and fluids from quite deep below, several kilometers below, were forced upwards. They were under pressure down there. When you opened the crack, it's steam, essentially. They were moved up because of the pressure from below. they precipitated out minerals in those and formed veins. Some of those veins have little extra minerals like silver, lead, zinc. There's very little here in the Burren. The main thing is calcite and some silica, some pores. So these calcite veins then sealed these joints, but then the water from the rain, from the soil, starts working its way through. These are the weaker joints. These are the lines of weakness, and water will always, if you have a leak in your house, you know water will always find the weakest point, and that's what happens. So gravity's pulling it down, and it flow down through these and dissolve them away. So what we are looking at in these grikes, these are actually the remnants of the collision of two huge continental plates 300 million years ago. And they're still controlling the landscape that we see now. They're controlling it in terms of where the water flows and in terms of the actual where things live, how they live on the landscape. So as some of these surface features on the limestone, all these, the way the limestone dissolves, it's called karst. And these surface karst features are controlled by the water. They're controlled by plants and roots, because water will percolate down through roots and it will flow along there. So in some areas, we can see remnants, or we can see evidence that there was soil on the limestone that is no longer there. So when you're looking at these curved furrows, for example, that doesn't form from just rain falling on the surface. That forms under the soil. So it's connected with roots. So that gives us other evidence that perhaps the limestone surface that we're looking at was not always like this. There may well have been more soil there in the past. And where did that soil go, or what happened to it? Well, as people arrived here around 6,000 years ago, they started cutting down trees. They needed to get heat. It was still like it is now, it's cold in winter. They were cutting down these trees. We know from pollen evidence, taken from cores in areas around the Burren, that there were more trees here in the past. So around 6,000 years ago, we see less trees and more grass. So they're cutting down the trees for fuel, but they're also then forming these expanses of grass where they're grazing animals. So they're changing from hunter-gatherers to farming people around that time. So 6,000, 5,000 years ago, they were pretty much farmers. But then as you farm the land and you cut down trees, you cause erosion. And these soils on the limestone are very thin usually, and once they're removed from the surface, it's a very slow process to get the soil to form again. The reason for that is because the limestone is very pure. It's got nothing in it pretty much, apart from those thin shale layers I mentioned. Apart from that, it's all calcium carbonate. When the water dissolves that, it leaves nothing behind. That water dissolves it, it flows down into the cracks, flows through conduits that are now caves, and flows away out into the sea. So most of the rain that lands on the surface here, anywhere in the Burren, it will flow down through these cracks into these water conduits, and it will be out of the Burren, either into the river that goes into Ennis or into Galway Bay or off here. In 48 hours, the water is gone. And it doesn't flow through the rock, it flows along these gaps. So they're essentially pipes. So the water that falls here is unfiltered. It just goes down, flows through, and flows out into the sea. This has an important consequence for how we manage our water resources here. So people who use the water for drinking especially, so you extract water from springs or wells, the activities of somebody 10 kilometers away can have a direct impact on your water supply because it's not filtered naturally. So this is a big issue in this area here. So water supply, water resources. But the water then is absolutely critical to the shape of the landscape now. In the past, when the water was ice, it carved out these great valleys. Now when it's falling as rain, it's making the water in the soil slightly more acidic, it's dissolving the surface, and it has done for at least the last 10, 15,000 years since the ice melted. But before that, there was warmer periods as well. When the ice was here, there was no water flowing, so it didn't really do anything. It was solid as ice. But in the warm periods between the ice, the water was active. And every time the water is active, it's dissolving the limestone. So some of what we see on the surface now happened in the last 10,000 years. Some of it happened 100,000 years ago, before the last ice. So it's all inherited. So we have a complex interaction between water on the surface and the surface of the limestone, forming all these intricate patterns that we see now. I think the key message is that we have to assume responsibility for our role. We are humans, we are part of an ecosystem. We are not separate from an ecosystem, we are part of it. a completely real and natural part of it. It's not like we're aliens that were transported down here. We grew up here, we evolved on this planet, we are part of the overall ecosystem. We have the responsibility and the advantage that we can change how we behave. So we can look for new technologies, we can control what we do with our waste. So we should be prepared to make those decisions because the consequences of not doing it are real. We know what happens when climate change accelerates. We can see it from the past, from ice cores in Greenland going back 100,000 years. We know that the climate change can heat up quite quickly. There are consequences to particularly what happens in the oceans. And that's something that people don't, I think, talk about enough. There's ocean acidification can happen. This can cause the death of the ecosystem, essentially, in the ocean. So a lot of our resources are involved in taking fish from the sea. That might just shut down, so some of these seas are going to die, essentially. That's an extreme, but there is a real possibility. The ocean currents may change as well, so the climate is going to change. As that happens, the sea level is going to rise because the ice is going to melt. As sea level rises, all the coastal villages, towns are going to be impacted. In the past, a mere 5,000 years ago, when humans came here, they were moving around. They didn't build rigid structures. What's happened since then is that humans have decided to stay put. They've decided to say, we're building this here, we're going to stay here, forgetting the fact that everything else around us changes. We've kind of ignored that. So we need to reimagine our role, I think, in the global ecosystem, how we fit into all these changing environments and changing conditions. The atmosphere is changing, sea level is changing. These are all natural changes. We are changing and we are contributing to the overall change. So I think we need to have a more integrated, holistic approach to how we plan for the future, how we live our daily lives now.
My name is Nuala Mulqueeney, and I am a director of Aillwee Cave and Birds of Prey Centre. I've lived all my life in the Burren region of North County Clare. I come from the village of Kilfenora, which is known as the gateway to the Burren. My parents, my mother, came from Germany to live here. My father before me and my grandfather before me all have been born and raised in this North Clare region. It's my home, it's my children's home, it was my father's home, it was my grandfather's home. So I'm very proud to be able to be living here 3, 4, 5 generations on. The Burren has a certain uniqueness that you will find nowhere else in the world. It is a limestone region of about 120 square kilometres, predominantly in the north of County Clare, and it goes into South Galway as well. The rock that predominates now in the Burren it's a limestone region, but it wasn't always like this. The Burren, as we see it today, was completely different up to 10,000 years ago. After the last ice age, it would have been very much a forested area, and yes, the limestone was there, but it was under layers of other types of rock, like shale and sandstone. It really would have been the intervention of humans on the land that has generated the different kind of landscape that we see today. They would have been at the beginning, maybe 10,000 years ago, in the late, I'm going to get this wrong now, it's the late Neolithic time. They would have been, the inhabitants to the Burren region would have been hunter-gatherer people who would have been nomadic and would have made their way throughout the countryside. As time went on, then they started to settle. And in the intervening years, from 10,000 years to maybe 4,500, 5,000 years ago, started to farm the land. In order to farm the land, they would have needed to clear the land. So hence, all the forests would have been cut down. Then, of course, what went on over the hundreds of thousands of years was the weather. We're on the west coast of Ireland. The prevailing winds or westerly winds, the rain from the Atlantic would start to wash away what the forests used to protect. So the forests, the woodlands were taken away, The wind and rain and weathering and erosion take away the soil layer, and then over time the shale layer, and that is how the exposed limestone layers that we see today were exposed by human intervention. There are still some areas in the upper lands, and the higher and the further south you go, actually from here in Ballyvaughan, further south towards the cliffs of Moher, at the tops of the hillsides there, you do still find some shale. Okay, shale was not so permeable to the water, right? But then as the shale was washed away, when the soil was washed away over thousands of years, the exposed limestone, that is permeable to water. So the water does seep down through it, through cracks and crevices, and it enlarges the cracks and crevices in the rock to form underground streamways, passageways, chambers, and eventually cave systems. You will find now in the Burren region that there is not so much overground water. A lot of the water that flows in the Burren is all underground. All right, so we have water, we certainly have lots of water in the Burren, but it's all in underground rivers and underground lakes that appear for a while, but then underground again, and eventually flow out to Galway Bay. You see, that's what happens in the Burren. There is underground water, okay, and then you have the water table, and what happens in then when we have rain, it's not just, the rain falls underground, but it floods what the underground bodies of water, not so much the rain just stops on the ground, no, from the sky. It goes under the ground, and the bodies of water that are underground begin to fill and fill and fill and fill and fill, and that's what you see then coming overground. So what we have are disappearing lakes and disappearing streamways. There's an Irish word for them, they're called turloughs. So what happens is, at times of very, very wet weather, it's the underground bodies of water that flood, come overground, okay? And you'll see there's a huge one in Carron called the Carron Depression, and it can flood. The rain stops, and the following morning, that's gone. Like a bath, you take the plug out of the bath, and it disappears once the rain stops. But that's coming from flooded areas underground to overground, not just falling down on the ground and staying there, because all the water goes underground. We're told it's a very, very old cave. It started to form over nearly 1 million years ago, but a lot of its more recent formation would have been after the last ice age, which they reckon was about 13,000 years ago. The cave, because of its height above sea level, it doesn't flood very easily. Hence, it was a good cave to open as a show cave, all right? But it formed in two distinct stages, or two eras. The first stage was a tiny crack in the rock, which, as the ice waters melted at the end of the last ice age, the water went underground, and this body of water grew and grew and grew, and with it started to enlarge a crack in the limestone. Okay, so we have throughout the cave tour, very much in the roof, you will see an arch shape, a semicircular shape, and that was the first pathway of this underground river that was growing and enlarging towards the end of the last ice age. Then as it grew, it looked for, I suppose, weaknesses in the limestone, okay? And on Aillwee Mountain, there are a series of weaknesses. They're known as bedding planes, okay? So this is a weakness in the limestone. It's where horizontal meets vertical limestone. So you'll have a layer of mud where the horizontal meets the vertical, and then that was washed away by the water, okay? So the water, you have to imagine the body of water growing, finding these bedding planes, these very, very weak spots, washing out the mud, and then the water going downwards and outwards and downwards and outwards. So that's the second part of the cave. If those bedding planes weren't apparent on the mountainside, you would have a complete circular passageway. At Aillwee, what we have is the half tube, the bedding plane, and then the chambers underneath. All right? So, and that whole process went on for hundreds of thousands of years, and then about 10,000 years ago, then the climate changed, and it is now dry enough in this region for no underground water to be flowing through the cave system anymore. That's amazing, being on the west coast of Ireland, but there isn't enough water anymore. So it dried up, leaving the cave passageways more or less as we see it and as we bring our visitors into it every day now. I hope not too much happens to it. I think I live here now. I think our practices as a tourist attraction in the region, we need to be very mindful of how we, carry on our daily lives and how we guide our visitors through the region and through the cave. We practice different ideals, like, we say to our visitors, take all the pictures you like, but don't take anything from the landscape. We are here as, I suppose, guardians, we're all passing through, all of us are passing through, from the nomadic farmers or hunter-gatherers 10,000 years ago to me now, we're passing through. The next 10 years, I know, probably, we saw a lot of snow this year, but I'm a believer that was a blip. I don't think we're going to get snow in this region as much as we did. We had it 30 years ago, and we've had it now again last year. Maybe again in 30 years' time. I might be wrong. I'm no expert, but for me, I would like it to see it stay the same. No change. For what I remember when I was young in the 1970s, it hasn't changed very much. Because I have walked the same paths through the Burren to my workplace, to my pubs that I go in the evening, to my whatever, and it hasn't changed very much. I would like it to remain that way going forward for my children. For me, I see little change. I see certainly changes in technology and that sort, but in landscape, from a landscape point of view, luckily I've seen very, very little change. Now, I do remember actually on Fanor Beach, which is out on the north coast here, between us here in Ballyvaughan and Lisdoonvarna. After one big storm we had, it was so big that the waves kind of mixed with the underground sands under the water and pushed the stands up along. So I certainly saw that change. It was a very apparent change quite quickly after one very, very big storm that we had, and for me, actually, I was with Eamon and he pointed it out, and I said, you're right, that bank of sand was not there before, and it was because of the high winds coupled with the high tides at that time. It mixed up, the weather was so fierce, and the gale force winds and the rains together and that high tide, it took the underwater, the sands at the bottom of the water, and turfed it further up the coast. So that's one thing that I certainly can say that I have seen in my lifetime, an actual change in the landscape physically over a short period of time.